most dangerous places on Earth sometimes appear completely harmless. There are places where the water is bluer than any ocean, yet powerful enough to dissolve metal. There are places where fire burns blue, while ice conceals a heart that has never stopped burning. Every place in this journey has forced science to rewrite something once considered undeniable. And it is all still unfolding at this very moment. Hidden in eastern Java, Kawah Ijen lies within a volcanic caldera stretching nearly 10 miles across. At its center sits the world's largest acidic crater lake, reaching a depth of 650 feet. The lake alone is deep enough to submerge 2 statues of Liberty stacked on top of each other. As night falls over the crater, streaks of blue light suddenly erupt from the fissures. They are not lava, but sulfur gas burning at around 1,100 degrees Fahrenheit, creating the illusion that the entire mountainside is flowing with blue fire. Just a few steps away, the tranquil turquoise lake holds liquid with an acidity below pH 0.5, nearly as corrosive as the acid inside a car battery. Every day, the path descending into the crater remains filled with the smell of sulfur, intense heat, and toxic gases. Through the dense fumes, miners silently carry between 150 and 200 pounds of sulfur on their shoulders, protecting their faces with nothing more than wet cloths, making this one of the harshest working environments on Earth. Yet the very water that seems capable only of destruction has become a subject of intense scientific interest. In 2018, it was used to demonstrate that similarly hypersaline and hyperacidic solutions could still exist in liquid form on Mars, even at temperatures as low as -130 degrees Fahrenheit. Kawah Ijen not only reveals how Earth operates under extreme conditions, but also shows that the very water once regarded as a force of death may help scientists imagine life on other worlds. Perhaps the strangest thing is not the blue fire, but the way a hell on Earth has opened a doorway to the universe. From above, Tolbachik looks like a giant fracture cutting through the snow-covered landscape of Kamchatka. Tolbachik rises more than 12,000 feet, towering above Mount St. Helens. A single eruption once produced enough lava to bury all of Manhattan beneath nearly 100 feet of basalt. Here, winter and magma collide without compromise. Lava flows hotter than 1,800 degrees Fahrenheit quietly creep across deep snow, while glowing lava bombs are launched more than 300 feet above the crater. Even before the lava appears, the ground trembles through continuous earthquake swarms, and the air quickly fills with the sharp smell of sulfur dioxide. Yet Tolbachik's greatest mystery lies beneath the surface. Lava tubes formed after past eruptions contain ceilings covered with molten rock stalactites, while nearby volcanic vents have produced more than 100 mineral species previously unknown to science, making this one of the rarest natural mineralogical laboratories on Earth. Those lava tubes are now helping shape humanity's future beyond Earth. Engineers designing bases for the Moon and Mars regard Tolbachik as a real-world prototype for self-sustaining shelters, suggesting that the lessons for human survival on another planet may already exist beneath these volcanic rocks. Even after decades of research, Tolbachik remains beyond prediction. Scientists successfully forecast one eruption, yet almost completely failed to anticipate the next, forcing them to confront rivers of molten rock and falling lava bombs to understand what the Earth continues to conceal. Perhaps Tolbachik is more than a volcano. It is a place where Earth's deepest forces are quietly rehearsing humanity's future among other worlds. On Flores Island, Kelimutu rises 5,400 feet above sea level, nearly matching the elevation of Denver, one of America's iconic cities. Just below its summit, the deepest crater lake plunges 420 feet, roughly the height of a 40-story building. Kelimutu is the only place on Earth where three volcanic crater lakes sit side by side while continuously changing color in completely independent ways. Within just a few months, they can shift from turquoise to green, deep red, or cola black. At the center of Tuanua Lake, geothermal activity pushes patches of yellow foam to the surface, while the surrounding cliffs are stripped bare by acidic gases. Because of these unpredictable transformations, NASA once compared them to the mood rings of volcanoes. Beneath that beauty lies an extreme chemical environment. Tuanua Lake has a pH of only about 0.5, acidic enough to corrode many materials in a short time. On the same island, the discovery of Homo floresiensis fossils in 2003 also transformed scientists' understanding of human evolutionary history. As clouds roll across the crater, the air fills with the smell of sulfur while toxic gases continuously escape through the fissures. Stepping just a few feet off the trail can mean entering a dangerous zone. For the indigenous Leo people, this is not merely a volcano, but a sacred place where the spirits of their ancestors are believed to remain among the mist. Kelimutu's three lakes do more than change color. They remind us that even the most tranquil landscapes can conceal geological and chemical processes that have never stopped. The greatest mystery of Kelimutu is not the color of its waters, but the fragile boundary between science, nature, and belief. Seen from above, Taal resembles a geological puzzle. An island sits in the middle of a lake. On that island lies another lake, and all of it rests within a much larger island. These nested layers of landscape make the place resemble a Russian nesting doll sculpted from water and stone. Taal is built like a geological labyrinth. A lake surrounds an island. On that island lies yet another lake, resting inside the volcano's crater. These overlapping landscapes form the largest known lake on an island in a lake on an island system. While more than 40 volcanic vents scattered across its surface make it feel like a world still unfinished. But the greatest surprise comes from life itself. It is in this freshwater lake that scientists documented Hydrophis sempery, the only sea snake known to have abandoned the ocean and fully adapted to freshwater. An entire ecosystem continues to exist atop an active volcano. Then the earth begins to speak. A deep rumble echoes across the lake. The air fills with the smell of sulfur, and columns of steam continuously rise from the water, reaching temperatures of around 170 degrees Fahrenheit. What appears to be a peaceful lake is in fact only a thin shell covering the restless energy still moving beneath the surface. At Taal, every layer of the landscape conceals another beneath it. And like the volcano itself, the greatest danger always lies where the human eye can never see. Not every volcano tells the story of the past. Some are still writing that story every single day. Deep beneath the Reykjanes Peninsula, a stream of magma rises from nearly 19 miles below the surface, almost equal to the length of Manhattan if it were stood upright. When it breaks through, lava fountains soar as high as 1,600 feet, towering above the Empire State Building. Fagradalsfjall does not appear as a single volcano, but as a labyrinth of tuyas, hyaloclastite ridges, and interwoven valleys. When the lava reaches Geldingadalur, it does not immediately rush down the slopes. Instead, it quietly fills the entire basin before spilling over its lowest rim, creating the rare fill and spill phenomenon, where brilliant rivers of fire flow slowly yet are almost impossible to stop. Standing near the edge of the lava field, temperatures exceeding 2,170 degrees Fahrenheit make the air shimmer like glass. The smell of sulfur dioxide mixes with smoke from burning moss that blankets the valley. After 3 weeks and more than 34,000 earthquakes, every tremor suddenly disappeared. That silence became the final signal before the ground split open. In 2022, scientists discovered that fresh magma could fully mix with the deep magma system in as little as 20 days, proving that Earth's interior does not operate as slowly as once believed, but is changing almost in real time. More than 1 million people once stood before this gateway to watch the flowing lava. 2 years later, the very same geological system forced the entire town of Grindavik to evacuate before a force that could not be negotiated with. What humans call an eruption may be nothing more than a few brief breaths in Earth's cycle that spans thousands of years. Few places on Earth allow the night to glow from the ground itself. Beneath the rim of Nyiragongo, a lava lake nearly 2,300 feet deep burns without pause, large enough to swallow one World Trade Center. As darkness settles over the summit, the lake of fire begins to move like a living creature. Black crusts continuously crack apart, drift away, and close again amid rivers of glowing lava. The secret behind this spectacle lies not in the size of the lava lake, but in its rare nephelinite rock. Its extremely low silica content makes the lava so fluid that it can race down the slopes at nearly 60 miles per hour, faster than any lava flow ever recorded. Standing on the crater rim, the sound of lava crashing against the rock walls echoes like ocean waves inside the mountain. The air is thick with sulfur dioxide and hydrogen sulfide, while the wind remains colder than 32 degrees Fahrenheit. Just a few steps toward a fissure, blasts of heat exceeding 170 degrees Fahrenheit suddenly rise from the ground, as though two opposing worlds exist within the same moment. What concerns volcanologists is not only the heat. In 2021, magma broke through to the surface just 40 minutes after the first seismic signal, so quickly that many long-standing forecasting models could no longer keep pace with the movement beneath the Earth. Directly beneath the city of Goma, home to more than 1 million people, magma continues to move silently at a depth of less than 1,600 feet, reminding us that the distance between everyday life and catastrophe is sometimes thinner than we imagine. Nyiragongo does not merely send fire into the sky. It is quietly rewriting the fragile boundary between humanity and the Earth. At Mutnovsky, ice and fire have never belonged to separate worlds. Beneath its glaciers lie two massive volcanic craters more than 1,300 feet deep, still quietly releasing energy comparable to an eruption of Mount St. Helens. Mutnovsky is where winter meets the Earth's mantle. Glaciers blanket the southwestern crater, while towering columns of steam from fumaroles rise more than 3,300 feet into the air. Across the mountainside, minerals stain the ground in bands of yellow, orange, and brown, while deep beneath the snow, ice caves continue to be carved by the volcano's own heat. Standing inside the crater, the ground trembles gently beneath your feet as if it were breathing. A deep roar rises from below, mixing with the sharp smell of sulfur, while fissures continuously vent blasts of gas hotter than 1,000 degrees Fahrenheit. Nearby, the black mud pots contain solutions with an acidity as low as pH -0.56, stronger than the acid inside a car battery. Even more astonishing is that sulfolobous microorganisms continue to survive and evolve in this environment. After 13 years of silence, Mutnovsky erupted again in 2026, while people continue to harness its geothermal heat to supply nearly 1/3 of the electricity for the nearby city. Within mud pools with an acidity of pH -0.56, powerful enough to corrode many materials, sulfolobous microorganisms continue to survive, proving that life always finds a way. Mutnovsky reminds us that the harshest places do not always stand against life. Sometimes, they are where life learns how to begin. Pacaya was not created by an eruption, but by the collapse of the mountain itself. A massive landslide of rock and debris raced 16 miles toward the Pacific lowlands, leaving behind geological scars similar to those of the Mount St. Helens disaster. That wound is still clearly visible on the mountainside. A collapse scar nearly 2,000 feet long and 260 feet deep cut straight from the summit down the slope, as though the entire mountain had been torn apart in a single moment. Across the black lava fields, lava flows continue to creep slowly downhill, where the remaining heat is enough for locals to bake Pacaya pizza directly on the volcanic rocks. The air constantly vibrates with infrasonic waves generated by Strombolian eruptions. Thick sulfur gases blanket the mountainside, while each explosion can release more than 2,100 pounds of gas in just a few seconds. At times, the entire southwestern flank suddenly shifts by nearly 10 feet, making the ground beneath your feet feel as though it is drifting away. Recent research shows that Pacaya does not operate like most volcanoes in Central America. Beneath the molten rock lies a vast crystal reservoir recording an ever-changing history of pressure and temperature, revealing a magma system far more complex than scientists once imagined. An entire mountainside has shifted nearly 10 feet without collapsing completely. At Pacaya, stability is sometimes nothing more than a pause between movements that human eyes cannot see. Lava flows always capture everyone's attention. But deep beneath those black rocks, the entire mountainside continues to move little by little, so slowly that almost no one notices. At Erta Ale, fire does more than rise from the Earth's interior, it is quietly pulling a continent apart. In the Dallol Depression, more than 400 feet below sea level, the movements beneath your feet are shaping the future of East Africa. As darkness falls, the black crust covering the lava lake continuously cracks open, revealing glowing streams of molten rock slowly circulating below. Convection currents constantly churn the lake, occasionally hurling splashes of lava over the bare crater rim, a place the Afar people have long called the gateway to hell. The spectacle is not merely the expression of an active lava lake, but evidence of geological forces that have never stopped moving. By day, temperatures across the Dallol Depression often exceed 104 degrees Fahrenheit. Even after sunset, the heat clings to the ground. Thick sulfur fumes mix with the deep explosions of bursting gas bubbles, making the landscape seem as though it is never truly silent, while the cold lava beneath your feet remains as sharp as blades of stone. What geologists discovered after the 2025 unrest was even more significant than the eruption itself. A magma dike approximately 22.5 miles long had forced its way through the Earth's crust in just 25 days, revealing the early stage of a process that could eventually create a new ocean in East Africa. Every fissure widening today does more than split the rocks beneath Dallol. It may be sketching the first coastline of an ocean humanity has never seen. What begins beneath Erta Ale will not end when the lava cools, because the continent itself is still continuing to transform. In the heart of the coldest continent on Earth stands a volcano that has never stopped breathing for nearly 1.3 million years. Erebus rises 12,500 feet above Antarctica, where permanent ice and a persistent lava lake exist side by side. What makes Erebus extraordinary is not its height, but the way fire and ice coexist only a few steps apart. Around the crater, towering ice chimneys form as hot volcanic steam escapes from below and freezes instantly in the extreme cold. Just beneath them, Earth's only continuously active phonolite lava lake keeps its surface in constant motion, occasionally throwing out anorthoclase crystals up to 3 inches long that are found almost nowhere else but Erebus. Temperatures can fall to minus 58 degrees Fahrenheit, while polar winds exceed 90 miles per hour. Every breath becomes difficult in the thin acidic air, and the atmospheric pressure makes an elevation of 12,500 feet feel closer to 15,000 feet. Scientists have even named a rocky outcrop near the crater Nausea Knob because of the frequent bouts of nausea experienced there. Yet the greatest surprise lies beneath the dark ice. Microorganisms survive through chemical reactions between basalt and volcanic gases, making Erebus one of the world's most important natural laboratories for scientists searching for signs of life on Mars. Every eruption at Erebus releases an immense amount of heat, while beneath the ice, life continues without a single ray of sunlight, challenging every limit once thought possible. Perhaps Erebus is more than Antarctica's volcano. It may also be a gateway to worlds that have never been explored. Dallol lies 410 feet below sea level, lower even than Badwater Basin, the lowest point in the United States. At the center of this depression, a volcanic crater nearly 2 miles wide rises atop a salt dome, as though the Earth itself were swelling upward from below. Nowhere else on Earth do colors emerge the way they do at Dallol. Brilliant green acid pools are scattered among flower-shaped salt crystals, salt lily pads, and mineral chimneys reaching heights of up to 13 feet. Every band of white, yellow, red, purple, and reddish-brown is created not by living organisms, but entirely by the ongoing inorganic oxidation of iron and other minerals. This is also one of the most chemically extreme environments ever recorded. Some hydrothermal pools reach a pH as low as -1.7, exceeding the acidity of many concentrated sulfuric acids used in laboratories. In 2019, conflicting studies over the existence of microorganisms turned Dallol into a key site for scientists investigating the ultimate limits of life and simulating conditions on Mars and Europa. Standing in Dallol feels like stepping onto a planet that is melting. Air temperatures frequently exceed 122 degrees Fahrenheit, while sulfur fumes and acidic gases fill every breath, and the ground continuously fractures over hollow salt chambers below. Amid this landscape, the Afar people still cut blocks of salt and transport them across the desert by camel caravan, continuing a tradition that has endured for centuries. At Dallol, water is no longer a symbol of life. It becomes a solution capable of surpassing familiar chemical limits, forcing science to redefine where life can exist. Each new layer of salt buries the one before it, yet this land continues to write another chapter in Earth's history that has never truly ended. Beneath the black lava fields of Lanzarote lies a world that is almost invisible. A volcanic labyrinth nearly 6 miles long cuts through the heart of the island before extending another mile beneath the Atlantic Ocean, reaching depths of more than 210 feet below sea level. From above, Lanzarote looks like a fragment of the moon that has fallen into the Atlantic. Nearly 68 square miles of basaltic lava blanket the island, where vast black slopes stand in striking contrast to its small white houses. The Jambios collapse pits open like windows looking directly into the Earth's interior. Beneath that layer of rock, Cueva de los Verdes reveals another world. Its basalt walls are sliced by a brilliant red band of lapilli, a rare remnant left behind by superheated steam some 21,000 years ago. Within that almost motionless darkness, more than 36 endemic species continue to survive, including blind creatures often described as the Atlantic's living fossils. Today, this volcanic labyrinth also serves as a natural prototype for NASA as it studies shelters capable of protecting humans on the Moon and Mars. Hidden beneath rock that appears long since cooled, La Corona preserves more than the memory of a volcano. It may also contain the first blueprint for humanity's future base on another world. The journey toward the future does not begin in space, but within the silent volcanic caves beneath our feet. Every exploration ends with the same realization. This planet still holds countless secrets yet to be revealed, countless mysteries still waiting for answers. And the journey continues.